In this video, we're going to peek behind the curtain and look briefly at the .NET framework, what it is and how it works and supports your applications. We're also going to talk about namespaces, and we'll look at several of the top .NET Framework class libraries namespaces that you can use within your application to extend its functionality. And then finally, we're going to look at how to navigate through the help system to find more information about classes in the .NET Framework class library. Okay, so what is the .NET Framework? Well, it's difficult to describe, so we're going to stay at a fairly high level in this video. So as a result, this video is probably going to be a lot shorter than the previous ones. Now, if you're really interested about the internals of how the .NET Framework works, what it does for you behind the scenes, there are several really good books that are available that go into a lot of depth on the .NET Framework. And a book is probably the more appropriate format for that type of material because it is more theoretical and less visual. So I would refer you to those. Both of these books are available from the Microsoft Press. They're titled Applied Microsoft .NET Framework Programming, and there's a version for C#, and then there's also a version for Visual Basic .NET. So make sure you get the version that you're most interested in. And I will warn you that this is fairly in-depth information, so it will definitely take you from a beginner to an advanced developer very quickly, but it might be a little confusing in the process. So just fair warning there. But that resource is available to you. Also, I provided a document that accompanies the videos that has some additional information about the .NET Framework and so on. Again, we're going to stay at a fairly high level, so let's talk about the different parts of the .NET Framework. As I've just alluded to, the .NET Framework is actually several things. First of all, you have the Framework Class Library, referred to as the FCL. Secondly, you have the .NET Runtime Host. And then third, there are a bunch of utilities and things that we'll talk about in just a moment. First of all, let's talk about the Framework Class Library, or the FCL. This is actually a series of classes that have methods that encapsulate common system or application-related functionality. Almost everything that's interesting that you'll ever want to do within your applications will require that you use the classes that are supplied within the FCL. Now, we've used the message box, for example. That's in the Framework Class Library. We've used the different controls from the toolbox. That's all contained within the Framework Class Library. If we want to access a database, or if we want to open up an XML file, as we'll do in the next couple of videos, those both require the use of the .NET Framework Class Library. Think of the Framework Class Library as a bunch of classes that are available to your application that you didn't have to write, but you get for free just by virtue of the fact that you're writing a C# application. There are probably hundreds, if not thousands, of classes, and there's probably no chance that you're going to learn about every single class. But you're going to be able to find out the ones that are most popular, the ones that help you accomplish what you're trying to do most of the time by usually either looking at code examples or reading books, or by using the help system, as I'll show you how to do later on in this video. The next part of the .NET Framework is the .NET Runtime Host. And you can think of this as sort of like a protective bubble that keeps your application and your computer safe. Now, that's really an oversimplification. It does a lot more stuff than that. But, for example, it manages permissions for your application, and these permissions are granted to applications to run on your computer based on where the code originated from, whether the code originated from the local desktop machine, or whether it was run from the internet or run from a corporate intranet. And so in that way, you can prevent certain applications from being executed automatically as you surf to a given website. Those applications may not be given the permission to access your hard drive, for example, but might be able to display a form on the screen. So there's different levels and permissions that are given based on where the code came from, whether or not the code has been signed with a digital certificate, and things of that nature. Also, the .NET Runtime Host provides a common type system across all .NET languages. So you could write a VB.NET application that can reference code that's written in a C# application, and so on. And that's fairly unique. That's not something that just comes automatically with any programming language. It took a lot of forethought and a lot of effort to make that happen. And then also, the .NET Runtime host makes sure that no memory is leaked. In other words, no memory is left over once your application has terminated, or as your application finishes using references to variables and references to objects, it'll clean up the memory, and so you don't have to worry about it. And then third, you have a set of utilities that come with the .NET framework. And these utilities include compilers, debugging tools, tools that automatically produce certain types of code or XML. And really, there's so many different utilities, it's difficult to put them into one container or another. Most of these tasks that you perform using these utilities are not something that you really need to worry about for the moment, since you're just getting started. So we're not going to cover them in any detail at all in this series of lessons. However, if you open up Windows Explorer and you navigate to Windows/Microsoft.net/framework/version 2.0 dot whatever is the extended version on the end, you can see that if you were to sort the applications or the files by type, there's a number of different .exe applications that are available, and all of these are the types of utilities that are accessible through the .NET framework. Okay, so now let's talk about how the .NET applications work. Whenever you create an application and you create an executable like we saw in the very first video, where we identified where the .exe file was saved in the bin directory, what actually happens behind the scenes? How does the .NET Framework runtime, for example, support your application? So that's what we're going to talk about now. First of all, whenever you compile your application, it creates what's called an assembly. An assembly is usually a file with a .exe extension or a .dll extension. And the code that's contained within this file is called intermediate language, or rather IL. It's a temporary language that will be compiled a second time whenever your application is installed on its target computer. So for example, if you were to create a .exe application and give it to a friend, and they're running Windows 98, it's going to then, the first time the application is run, compile a special version of your application using the .exe assembly, using the intermediate language inside that assembly, that is specific to not only Windows 98, but also the specific processor and the amount of memory and things of that nature. It tweaks the application to perform optimally on that system. If you were to give the application then to a different friend, it would go through that same compilation step where it determines the operating system, the processor, and other features about that person's system, and compiles a version of the application for use on that computer. This is called just-in-time compilation, and it's a unique feature of the .NET framework, and it's something that allows your applications to run smoothly regardless of the operating system, as long as it's Windows-based, regardless of the processor speed and things of that nature. The application will be tuned up automatically without you having to do anything about it, so that it runs as best it can on that person's computer. Now, when that person actually tries to execute the application the first time, it goes through this just-in-time compilation step. And then all subsequent times, what will happen is it will use that optimized version of the assembly in order to run from that point on. So that compilation step only happens once. When the application is running, the runtime, the .NET runtime, will host the assembly. Now, what does it mean to host the assembly? Again, that's a little bit difficult thing to explain because it does a lot of things. Some of the things that we described earlier, where it protects the computer from memory leaks, protects the computer from malicious code that might be written based on the credentials of where the application was originally launched from, and looks for security violations and things of that nature. The runtime also provides access to the framework class library, so that the application can access the file system if it needs to, or access a database, and all the things that the FCL will allow the application to do. So the runtime provides access to those classes. And then, like we talked about earlier, whenever object references and variables are no longer needed, those items are removed automatically from memory by a special feature of the .NET Runtime host called the garbage collector. So it goes around and looks for things that are no longer being used, and it removes them from memory. And so you don't have to worry about cleaning up memory or anything of that nature like programmers in the past had to do. That's all taken care of for you. So you can just concentrate on creating the core functionality of your application. Now again, all of this functionality is provided for you without you having to explicitly call the runtime. When somebody tries to execute your application on their computer, the .exe file will tell the computer that it requires the .NET runtime in order to run. And if the user doesn't have the runtime, then they'll get an error message on their screen that telling them that it requires the use of the .NET runtime, and I think it even gives them the location where they can download the runtime so that they can run the application. If they've been keeping their Windows their version of Windows updated with the latest security patches, they should have the most recent version of the .NET Framework runtime. However, whenever you create an installation program that places your application on their hard drive and does things like creates a nice icon in their start menu and things of that nature, it can also include the installation for the runtime. So if somebody doesn't have the particular version of the runtime that you've compiled your application with, then it can install that as well during the installation routine. So if they have the .NET runtime, then the program will simply execute. It's as easy as that. Again, it's not really crucial that you understand much about the .NET runtime or any part of the .NET framework at first, as you're just getting started, but just know that there's a whole support system that won't allow your application to fail or break somebody else's computer, which is a fairly comforting thought. Okay, now we're going to completely switch gears and talk about namespaces. Now we've seen this word namespace many times as we've been developing our application. Here I have a new project called Lesson 7 that I've already taken the liberty to create, and you'll notice that by default we have a namespace called Lesson 7. And notice that the namespace defines a code block in which your classes must live. So we noted already that methods and properties and fields have to live inside of a class, but classes have to live within the context of a namespace. Now, the purpose of a namespace is that it helps you write code to avoid naming conflicts. Let me explain what that means. Suppose you work at a big company. In particular, let's use the previous lesson's example of an auto manufacturer. And you work there and you create applications for the finance department within that auto manufacturer. Now another programmer at that same company, he happens to work in the engineering department, and for years you're both developing .NET applications, and you've both created a car class. Now your car class looks dramatically different than his car class. But one day you're asked by management to work together to build a new application that merges both departments. And you realize that you've got a lot of the code already written, but one big problem exists. Since you both have a car class, .NET may not know which car class to use. Each car class has a different properties and methods defined, so using the wrong car class might, blow up the application. So what do? Well, fortunately, as long as you use different namespaces, you're going to be okay. For example, you might have the following namespace: Great Cars. Maybe that's the name of your company. GreatCars.finance, which is your department, .car. And your counterpart's namespace, who happens to work in engineering, is GreatCars.engineering.car. Now, this is what you call a fully qualified namespace, or fully qualified type name, because it uses the full name of the car class to differentiate the two classes from each other. You can think of namespaces like full names, at least in the American culture, where you have a first name, a middle name, and a last name. Okay, your surname. My name, Robert Tabor. Now, it just so happens when I moved from my home near Chicago, Illinois, and I moved down to Dallas, Texas, that there was somebody else in the town I lived in, near Dallas, that had the same name, Robert Tabor. So we had a naming conflict. There were people that would call my house and look for their bowling buddy, Robert Tabor. Well, that was not me. I don't belong to a bowling league. The way to differentiate my name from his name is that I'm pretty sure that nobody has my middle name, which is Robert Theron Tabor, fairly unique name. So by using the fully qualified name, it would be easy to differentiate me from the other Robert Tabors of the world. So we can apply this to our own application, like from the previous example in lesson number 6, whenever we were creating a car class. So let's just run through a quick example of how we can create our own namespace there. So what I'm going to do is just add a new class, and I'm going to call it car. And by default, it gives you a namespace in C# that is the name of the project. Now you can change this namespace to whatever you want it to be. In our case, let's use great cars dot finance. So great, I've created a new namespace and I can use it within my application. I'm going to go ahead and save my app. Now we're not quite in the clear here. Let's go ahead and try to use our car class. It doesn't really do anything, but let's just create an instance of it like we learned how to do from the previous lesson. Car, my car, equals new car. And let's run the application. And it says there are problems. The type or namespace car could not be found. Are you missing a directive or an assembly reference? So we get that twice within that same line of code. What's the problem here? Why can't it see our car class that we created when it worked so easily in the previous lesson? Well, the reason is because the context that we're running under, the namespace that we're running under, is lesson 7, the default namespace for our Form 1. If we want to use a class that's in a different namespace, we're going to have to tell the C# compiler where to expect to find it. So what we're going to have to do is this. Greatcars.finance, see the IntelliSense that pops up? .car equals new greatcars.finance.car. Now let's see if we can run this application. And it works. Doesn't really do anything, but hey, it compiled, so it must work, right? No, I'm just kidding. Okay, so obviously there's a lot of typing that needs to be done, and this is very inconvenient. And what we can do is truncate all this off and use a shortcut called a using statement. Now, at the very top of your file, you'll see that there's already some default using statements that are supplied by the template that allows you to create a form. So we can add our own using statement as well and just paste in greatcars.finance. Now, whenever a car class is referenced, we don't have to declare the fully qualified type name or fully qualified namespace, because the using statement is kind of like a shortcut. It does that for us. So now when we run the application, even the shortened version, it compiles and seems to work. Okay, so here's the trick. Let us go back to our car class. Now here's something, another little interesting thing. We can add more than one namespace, more than one class to the same file. So don't let this confuse you. A file has nothing to do with the actual namespace or classes or anything that are defined therein. So let's go greatcars.engineering. And here we will define a new class called car as well. Okay. So what's the difference between these two? The only thing that's different between these two is the namespace that they each belong to. Okay. So how does your application know to use the car that comes from finance? It looks to the using statement. Now I'm going to confuse the compiler and do this. Watch this. Greatcars dot, whoops, let's get the case correct, engineering. Notice we now see in our Great Cars namespace, there's two sub-namespaces, engineering and finance. We'll put engineering here. And now we'll run the application and see what happens. Uh-oh, problem. What's the problem here? It says car is an ambiguous reference between greatcarsfinance.car and greatcarsengineering.car. In other words, we use two using statements, and both of those namespaces contain car. C# throws up its hand and says, I don't understand which car you're referring to. So in that case, we would have to use the fully qualified namespace. So again, don't worry about this. It's not critical, but the only reason I bring it up now is to introduce the concept of namespaces within the .NET Framework Class Library, the FCL. Whenever you find a class that you need to use for your application, whether it's to access a database, open an XML file, open a file on a hard drive, write a form to a screen, whatever it is, you're going to need to either use the fully qualified namespace or take the time to create a using statement that will include the namespace for the set of classes that you need to use. So as you see here, there are several using statements that are supplied by default. If you wanted to use, for example, something that helps you work through security issues with your application, you might do something like system.security. Or if you want to work with, for example, let's just go through here and look at a few, media or input-output, I/O, or diagnostics in order to determine how your application is running, or a number of different things. There are a number of namespaces under the system namespace, which is the top level namespace for the FCL. Okay, so for example, if we wanted to work with isolated storage, which I know you don't know what that is, we would just include that using statement, and now we could use all of the classes that are supported by that namespace without having to reference system.io.isolatedStorage.whatever every time we wanted to use that class. Okay, so that's why we're able to use MessageBox without having to type system.windows.forms.messagebox, because .show, and here we'll just do hi. Why don't I have to type that every time? Well, look, notice that by default, that is a using statement that's included in every form that you create using Visual C# 2005 Express Edition. Okay, so the next question is, what classes can we use within our applications? What namespaces can we look to? And what you see on this slide is a number of the most popular namespaces that will allow you to do things. And keep in mind that there's a lot more, and this is just a starting point for you. For example, we've already looked at system.windows.forms. This gives you access to all the form and control related classes. System.data, as we'll see in the next couple of videos, is kind of the behind-the-scenes classes for all things that are related to data access, the data set, and the various other database-related objects. System.net allows us to communicate with the internet. We can actually use system.web in order to create web pages, ASP.NET web pages, and there's a bunch of classes related to that as well. System.io allows you to retrieve and read text from external sources like files or the internet. It includes classes like the stream class and the text reader, and we'll be using some of these in our RSS reader application. The system.xml class, which we're going to look at in a couple of videos, allows us to retrieve and read XML. It has classes like the XML text reader, the XML document, and again, lesson 10, we'll talk about this quite a bit. System.text, it gives us ways to work with strings, like concatenate strings in a much more effective way than what we could just use with the string class by itself. It gives us a class called String Builder, which optimizes our ability to work with strings. And there's quite a few others. These are just some that I wanted to point out to you. And now the next question you might be asking yourself is, how did you figure all this out? Where did you find all this information? Again, I think I said this earlier in the lesson. It's going to take a lot of time. You're going to have to, watch videos. You're going to have to read articles, read books, go through the help system, which is what I'm going to demonstrate next. But you start learning about the various things that are available to you by practicing, by experimenting, by reading and looking at other code that other people have built, or having a question in your mind, I wonder how I do whatever, and then getting on a search engine and finding a particular reference to that somewhere on the internet. Those are the best ways to learn the language, to really get in, and I mean not the language, but the class library, to find out all the things that are available to you within the FCL. Okay, finally we're going to take a look at how to use the help system in order to find and view members of classes. And this is actually really easy. There are several ways that you can use the help system to search for a given class namespace like system.windows.forms or whatever the case might be, or just drill through the contents of the help, or to use the index to type in some keywords and hopefully they'll come up with what you're looking for. There's also this dynamic help, which I usually like to, let's drag this window down here. Let's put it there. I don't think I did that right. Oh well. But at any rate, while you're typing sometimes you can find, for example, system.xml, and you can see that there is dynamic help available to you that is context sensitive. So whatever you're typing, it will try to provide articles in the help that relate to what you're typing. So we can just click on it and then see information, in this case about the system.xml namespace. There's also another easy way, and that is to just use your mouse cursor or use the arrow keys and the shift key on your keyboard to highlight certain keywords, or in this case a namespace, and then hit F1 on your keyboard like you can in all Windows applications, and this will bring up your help for that particular item. Notice that the help is displayed in a tab just like the other items in the main area, and as such you can create a horizontal tab group and kind of view both code and help at the same time if you want. Let's go ahead and move that back by selecting Move to Previous Tab Group. And now when we're looking at a namespace within the help system, we can start just navigating through using the links that are available. So for example, if we wanted to find out more about, let's say the math class, system.math, we can drill through and learn more about that class. Okay, and see some examples in code and so on. You can see the difference between, for example, Visual Basic source code and C# source code. You can copy and paste this directly into your project and run it as a test project just to see how it works, set a breakpoint, and so on. So I encourage you to take a lot of time, just browse through the help. That's the most helpful thing that you can do whenever you're developing your applications. Now, what if you find a section in help that's particularly helpful? How can I bookmark that and get back to it? Well, you can see here that this is laid out like almost a web browser where you have a URL for this help that's located on your local machine. So what you can do is select it, and I believe you can just right click here and we'll select copy. And now let's come over and do like we did in a previous video and just paste that link in. And now whenever we want to look at the help that's related to this section of code, we can hold down the control key and click that link, and we'll open up that tab in our main areas to get back to it. So that's a very useful tip. Okay, so in this video we covered a lot of space in regards to the .NET Framework, the Framework Class Library, the .NET Runtime. Didn't talk a whole lot about the utilities, but we did talk about namespaces and why they're useful, and we looked at some namespaces of the .NET Framework Class Library and how to find out more information about the various classes and namespaces that are available within the Framework Class Library through the help system. So I hope this video was helpful to you in that regard. Again, we just scratched the surface like most of these videos that we've looked at up to this point. You don't have to memorize all this information, but just know that it's available out there to you and that there's kind of more going on behind the scenes than meets the eye when you're first developing your Hello World application and so on. So if you enjoyed this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.NET, and more. Thank you.